Good morning, everyone. I hope you enjoyed the keynote in your first session, and welcome to my talk about opinionated Ktor services. I'm Simon. I'm a developer advocate at JetBrains. And for the last 10, 11 years, I've been working with Kotlin in the open source space on projects like Arrow and other libraries with and without Ktor. I've been building enterprise systems with Ktor for the last 7 years, serving millions of users. And I've also been giving trainings to many teams on Kotlin with and without Ktor. So today, I want to demystify a little bit my opinion on how to set up a Ktor service, because Ktor is a plug-and-play system. It leaves some choices to the user for better or worse. So today, I want to give you an end-to-end picture how we can build a Ktor Gradle-based project and how we can eventually deploy that in the cloud with all the features that we need for a modern service. So we start with our Gradle build and settings file. And when we are managing dependencies in Gradle, we typically think about version catalog because it is the easiest way to manage your dependencies. And Ktor exports and publishes a version catalog. And once you have imported this into your project, you can very easily use the typed accessors to set up your Gradle dependencies in your project. This also allows for very easily browsing all the modules that are available in Ktor without having to manually manage your version catalog. To set up your Ktor project, you can use the Start Ktor website or the IntelliJ wizard to very easily set up your Gradle, Amper, or Maven-based projects. Soon, also the Kotlin build tool. You can select various plugins, and for every plugin you select, an example file will be generated. Sadly, these example files are not integrated in a production way, but we have just rolled out a new generator platform, and we will be working on generating more production-ready templates in the future. In the meantime, you can use my Ktor's Quick Start template, which is also set up with agent skills and an agent MD and an opinionated project structure. You can efficiently start building your Ktor services in Kotlin. I will share all the links at the end of the presentation. But now that we've set up our project, let's see what code we or our agents will be writing. So we have our Gradle project set up, and we're going to start by creating our server and configuring our server. And I like to take full control of my main function and my application, so I prefer using the embedded server DSL. And here I'm using the embedded server DSL with the netty engine, which has become the default choice for building services on the GVM, unless you have a very strong reason to use something else. When we have created the embedded server, we always need to explicitly start it, and typically we want to wait until the server stops before we exit, right? So we set wait to true. Inside of the Lambda, we get access to the application type, and the application type is the heart and soul of the Ktor DSL. It is also a suspending Lambda, which is very powerful because you can do suspension at startup, because it's also a bit dangerous because you don't want startup to take a long time. But we'll get to that later. Our configuration typically lives outside of our code in application files. I have been using YAML for quite some time, and it seems to have become the standard for DevOps. And it supports string interpolation, as we know from Kotlin. And here, Ktor will substitute the host import with available environment or system variables. If they are not available, it will fall back on the fallback value. You can also omit the fallback value, and in this case, the host is a required environment or system variable. If it is not available, loading the configuration will fail fast. So to work with this application configuration in our code, we want a typed representation, so we create a serializable data class that matches the key value pairs from our application config. There's also support for more complex types. There's actually support for any serializable type, but I would advise you to not put complex types in your configuration, so stick to primitives, collections, or enumerations. I personally like scaling my application config by defining individual maps in my application file, and it allows you to define separate data classes for every configuration concern that you have for your server. So how do we actually load our application config? We use the application config class, and we specify the file we want to load. And then we can use the getAs function to deserialize the application YAML into our data class. And this will use colon X serialization under the hood to read and deserialize the YAML and then turn it into our class. You can also load multiple files and merge them together, and this allows you to share your configurations among different modules and share them amongst different services and then aggregate them together. And here, the second application config file will override keys that already exist in the first application config file. So now that we have our configuration loaded, we can configure our service, and we've now effectively bootstrapped our Ktor service, and we are ready to start writing routes, right? So first we will load our configuration. If it's not properly available, we will fail fast. If it's available, we'll set up our server and move on. So now it's time to start writing routes, and I prefer working with a package by feature or package by domain code structuring. So here I have a simple post package which contains all concerns for posts, domain, or feature, and similar for profile, instead of grouping them by technical layer, because I like things that belong together to be together in the code structure. So inside of the embedded server DSL, we had the application type available. On the application type, you can create a routing block, and in the routing block, we can create route handlers. And the core of the route handler DSL is the call property, or the application call type, and we can use it to receive incoming requests and to prepare responses for the user. In this case, sending a plain text get post value. So how do we extract values from the request? Here we have a name query parameter, which we store in a name Kotlin property, but this is a little bit redundant, right? We have to re-specify the name, and we can use Kotlin property delegation to avoid this. So here, Ktor knows the name of the Kotlin property, and it can use the name of the Kotlin property to extract the value from the query parameters. Here we are still dealing with the raw nullable string value, but property delegation is smart enough to know the actual type, right? So we can also use a non-null type, and in this case, if the value is absent, Ktor will send a batch request to the user. But it can go beyond that, because property delegation can see the type. It can also convert to types like long, right? And it also, of course, also supported for path parameters. And in that the case that the incoming query parameter or path parameter is not of type long, Ktor will again send a batch request to the user. There's, of course, also support for type conversion with nullable types. There's also support for multiple parameters as collections. And there's also support for enumerations. There's also support for some JDK types like UUID. And now that UUID is stable in the Kotlin standard library, this will very soon be supported by Ktor. But since it's bad practice to have more complex types as path and query parameters, this is not supported, and you should avoid doing so. But what about value types? I like to have strong types at the boundaries of my application. So instead of working with raw primitives, I want to have a value class as my incoming value from the request. So how can we achieve this similar syntax that Ktor has? Well, we can define a function, which is an extension on the application call type, and we can use the application call DSL inside. And here I'm using get or fail, which will get the value from the query parameters. It will send a bad request, in this case, if it's absent. And otherwise, I'm converting it to UID. And here I'm throwing a parameter conversion exception when it is not the correct type. And the parameter conversion exception is exactly what Ktor does in property delegation. So we are piggybacking on a mechanism from Ktor to achieve the same functionality. Here I'm still leaving the name of my parameter as an argument, but maybe for a post ID, you don't want to leave this freedom to the caller of the function, but you want to enforce that the key for this parameter should always be post ID. And so how can we achieve this Kotlin property automatic extraction of the value? Well, we can create a read-only property, which can be used by the by keyword, and then we can use the k property to access the name of the defined Kotlin property, right? And here I'm simply using UID, because again, if it's specifically a post ID, maybe you want to fix it to that specific name to be more strict about your types. So how do we receive request bodies? You use the receive function, which is a suspending body function, which means it supports asynchronous bodies, which is extremely powerful, but you need to be aware that this loads everything into memory. So when you're working with very large payloads, you need to use receive channel such that you can stream the incoming value from the call next channel. Otherwise, you might go out of memory trying to load everything at once. So how do we structure our routes? I follow the same principles as I do with testing. So I have 3 phases. I have my setup phase where I extract values from the incoming requests. And here we have partial validation, right? We are checking absence of values. We are doing type conversion, but we are not yet checking runtime values, right? So I'm not doing any coercion. I'm not checking for certain ranges. I'm just checking the type and the absence. In my service layer, I do additional validation, and typically I only have a single service call in my route. So if your routes are growing complex and you have a lot of stuff going on here, maybe it's a sign that you're doing too much things in your route handler and you need to move this logic to a service. So when your routes become too complex, consider moving that logic to the service. And finally, I always do explicit conversion of the service type to a response, and I do not rely on exception for domain errors because I want to be explicit about the domain errors that can occur. So for truly exceptional things, you should still use exceptions, and in those cases you can use status page if you do not want to serve 500 internal server error to your users. Here I'm simply using nullable types, but sealed interfaces and rich errors will be a really great option for values to be returned from your service. So how do we group our routes? Well, whether you're working with package by feature or package by technical layer, we are typically already grouping by URL. And of course, here we do the same, and we can create a root block that allows us to omit the posts prefix from every route handler. Right, so every route handler we here define actually has the posts URL than whatever we have in the route handler. And this also typically gives a really good grouping for our services, right? We're packaging by feature, so this file is defined right side along the service, and this post service typically tailors what we need for our routes, right? As I mentioned before, if things become too complex, maybe consider creating a new service for your routes and then orchestrating the logic in your new service. So we were setting up our routes right in our embedded server DSL. And where are our dependencies coming from? Also from within the application DSL. But I do not want to couple setting up my routes and my server with bootstrapping of my production server and creating my production dependency graph. So I create a split, and I define a separate app function which defines my routes and potentially installs any plugins that I need for my routes, like content negotiation, which will be used to resolve the serializers for incoming requests and serializers for outgoing responses. And here I'm setting up Kotlin serialization with the content negotiation plugin. This also allows for very easily writing complex integration test suites by simply reusing our app function and passing in a test version of our dependency graph. And I prefer using test containers so that I can simulate very closely to what I'm actually doing in production, so you can get very high confidence integration testing. But if you want to do more fine-grained route testing, you can of course also very easily do that. In this case, you need to remember that you need to install any plugins that you might be installing in the app function. And here we are providing only a test version of the service, which again, I prefer to do using test containers. If I'm not doing test containers, I'm probably using stubs, and I avoid using mocks. So we have our routes, our server configured. Now it's time to talk about dependencies. And I like to do what I call explicit DI management, but I don't want to go too deeply into it. There are other great options like Metro and Coin. A lot has changed in the last year in regard to dependency injection, and all these frameworks are now offering compile time checks, right? So you can be confident in your dependency graph. If you're using explicit dependency management, like I've been doing for a very long time, I've never seen this really grow out of hand. But what if you have 25 different modules? Do you really want to keep a class with all these 25 modules? Well, as I mentioned before, we can very easily split our code, right? So we can split our configuration files for our feature modules, and we can aggregate them together. And instead of having a root dependency graph with all your modules, you can just have a dependency graph with your common dependencies and then maintain separate dependency graphs for your feature modules. If you're not building in modular monolith like this, you're probably doing microservices, and you probably won't have this problem. So what do I want to emphasize on today? I think it's good practice to make the application a part of your dependency graph. Right, so in this case, we are initializing an Hikari data source, which is a database connection pool, which we can configure with our application config. And when the application is stopped, we want to close this connection pool, right? Because we are running a lot of services, we are already burning a lot of money on tokens, we want to save some money in the cloud, so we want to close things when we no longer need them. And if you're doing explicit dependency management, it might look something like this, where you create your auto-closing data sources, and you encapsulate all the low-level machinery of your service, and you only expose the services that you need to configure your routes. Right? So encapsulate everything that you can and expose as little as you can to your routes. So I've managed application lifecycle, so let's discuss it a little bit. Everything starts by calling start on our embedded server, and when we call start, the application will go into starting mode, so Ktor will set up the application, and it does so by installing default pipelines and intercepting for routing, and installing a shutdown hook listener. Once that is done, it is time to call the user function, right? So this is our function from the embedded server DSL, which is creating our dependency graph, installing our plugins, and setting up our routes. When the application is entirely set up by Ktor and ourselves, finally it's time to start the underlying HTTP engine, in this case, Netty. And as Netty has finished starting, it is finally The server is finally ready, and it's listening at the configured host import. So the startup time of our servers is defined by the time it takes Ktor to set up the application, our user code, and the time it takes to start the Netty engine. But Ktor is very lightweight, Netty is very fast. For practical reasons, the startup time is defined by whatever you do in your code. The plugins you install, the things you set up, the SDKs you need to load, right? So you have very fine control over the startup time. So our server is listening at the host import, and at some point we will receive a termination signal, or the outside process will receive a termination signal, and the shutdown hook listener that we installed during startup will trigger the application to stop. And this goes into application stop preparing, because we need to do the same things, but in reverse order. So we first close the Netty engine, and closing or stopping the Netty engine means that you need to handle any in-process or in-flight requests, right? You don't want to abort ongoing work, so we first finish what we were doing. When that is done, the application can stop. And again, for practical purposes, stopping the application means calling cancel and join. And if you're familiar with Kotlin Coroutines, you might know that this means that it will stop or cancel all running coroutines, and it will await for that to complete, right? So after this is finished, after the application is stopped, you are guaranteed that there is no more running coroutines, right? And this is also the perfect place to do things like flushing your buffers, committing your offsets, and so on. When all of that is finished, it is the perfect time to clean up our dependencies. So I mentioned coroutines, so let's very briefly recap. And if you're interested in more details, you can check out my talk from last year. But it is safe to call launch directly on the application type, because the application type is always guaranteed to be a supervisor job, which means that if something goes wrong in this coroutine, it will not cancel its parent, right? So it's safe. When the application stops, our delay function will get canceled, and that will make sure that this coroutine finishes. So what about more complex use cases like event handlers? Well, here I have an event handler, and my async client is using Project Reactor. My session is using completable future, and I'm willing to give a beer to whoever can guess which frameworks these are, because this is a production example. And Kotlin Coroutines allows us to very easily integrate these different SDKs that we need to work with. And the async client returns a flux of received message, which we convert to a flow, and that gives us the guarantee that everything Project Reactor does, like back pressure, is maintained. And inside of our make function, I'm using execute async, which returns a completion stage, and I can simply await that. And this guarantees, through Kotlin Coroutines, that the session can back pressure the messages that we're receiving from our async client. We then simply launch this into the scope. I do also want to reiterate that you need to carefully think about exceptions that can happen here, because this coroutine is meant to run for the same lifecycle as our application. So you need to be wary about exceptions in retrying. Maybe you want to reconnect, but if that fails, maybe you need to send an alert, because you don't want this stream of messages to just silently stop, right? You want to be aware if something goes wrong. So think about this carefully. So where is this scope coming from? I already mentioned you can just use the application scope, but you should always explicitly set a dispatcher, right? So that hasn't changed. Always set a dispatcher. What if you don't know where your coroutine scope is coming from? Well, you can create a new coroutine scope, which inherits from the original scope, And we explicitly set the supervisor job, right? Because we want to guarantee that if something goes wrong in our services, it cannot cancel the parent, right? We want our server to keep running. And again, explicitly set a dispatcher. So how can we rely on this in services? Well, there's typically two use cases, which is long-running job. So you can just use this scope and launch a long-running coroutine when processing a request. Or maybe you need to run things in parallel, and then you should use the coroutine scope builder, which allows you to create async coroutines, and it will not finish or return until all the coroutines inside of the coroutine scope have finished, right? So this way you can guarantee that everything that happens here is finished before you send a response. So we have set up our server, we have set up our routes, we have created dependencies and services. Now it's time to secure our application. So our Ktor service is running, and at some point we need to communicate safely with the mobile application. And we don't want to implement security ourselves, so we rely on a third-party provider like Auth0, and typically the mobile application will use some kind of a SDK to get the token, and our server needs to communicate with this provider to get the certificates to validate these tokens. And this is not really a feature or domain concern, but it's more like an infra concern. So I create a separate package for it, security, and there I define my security configuration, my JSON Web Token configuration, and we will talk about OAuth a little bit later. So for setting up JSON Web Tokens, we don't need a lot. We need an URL to the third-party provider. This is a project-specific URL, so this is the URL for one of my examples. And you need a client ID, which is the ID that you've configured for this specific project, right? So that the provider knows who we are. And for connecting to the OpenID provider, we commonly use OpenID auto discovery, and this is not yet supported in Ktor. I'll mention this in a second. But following the OpenID auto discovery protocol, we can go to the /well-known /OpenID configuration URL, and that will contain all the information we need for connecting to this provider. And here, I'm only interested in the JSON Web Key URI, which holds all the certificates that we need to validate any incoming token. So we configure a JSON Web Key provider, which automatically fetches, caches, and rate limits calls to the provider. This allows for things like certificate rotation and so on. But for all purposes, this is effectively boilerplate code. Here we can finally set up our authentication provider for JSON Web Tokens using this JSON Web Key provider. You need to explicitly set a name for the provider, in this case bearer, and then we can configure the verifier with additional claim checks or leeway for expiration and so on. And this will guarantee that any incoming token is not expired. It is signed by the correct issuer by validating the public certificate against the signed token with the private certificate, and it will make sure that the token was created for our client ID or service. There's an optional validate function that you can specify for additional validation, but because I like to keep things stateless, I only use it to convert the Ktor credential types into my own custom domain. To protect our routes, we wrap our routes into the authenticate block, and we specify the provider that we want to use for checking our tokens. And sadly, we still have to deal with nullability, even though authentication is mandatory here. And here I'm returning unauthorized, but this branch will actually never be called. So I can pretend that this is not the case, and I will just use bang bang. But to make myself feel better, I will split it into a function that I hide somewhere else. And I will just use call.userSession. Luckily, we have thought about this, and if you're not familiar, we have a Ktor library improvement process, which is very similar to the Kotlin keeps. And here we create proposals that we intend to implement, but first we want them to get reviewed by the community such that we can collect feedback and pain points from everyone. So if you're interested, please check out the clips, read them, leave some issues, leave some comments, leave your feedback. Right, and here there's a type-safe authentication DSL coming such that we can avoid this nullability of the principal and we can more strongly type our principal types. And we have also planned a better OpenID support such that we can avoid all the boilerplates that we just discussed. So now we have protected our server for mobile applications, but what about web apps? And web apps are slightly more complex because we need to think about login flows, logout flows, registering users, refreshing tokens, managing sessions, and so on. So for this, we need one additional configuration, which is the secret, so that we can prove to the provider that we say that we are who we say we are. And then we configure our OAuth configuration, and again, this is quite some boilerplate. So what are we doing? We're using our discovered OpenID configuration to set the authorization endpoint and the token endpoint. We use our application configuration to configure the client ID and the secret. And actually, the only critical part that we are here configuring is the scopes. And I'm requesting the OpenID scope such that my token will include an ID token. I'm requesting basic profile information, which is name, email, and profile picture. And I'm requesting offline access. And offline access is needed such that it will include a refresh token, such that you can automatically refresh the token for the user. We also need to specify an HTTP client that allows us to configure things like retry mechanisms or rate limiting. And we need to specify a callback URL, which is where the OpenID provider will come back to us after a login flow has finished. I set up a login route, which I leave empty, and Ktor will then redirect the user, in this case to my out0 login page. We configure the callback URL, and in case that login was successful, we will get an OAuth2 principal, we will get an ID token. If both are present, we can set the session, and we can redirect the user to the home page. In the case that it was not successful, we don't want to send unauthorized status codes to the user because this is meaningless for the browser. Instead, we want to redirect them to some login failed page. So how can we safely deal with our sessions? We need to make sure that we do not send the sensitive information to the user. We want the session to remain on the server. So we use session storage. And in this case, Ktor will only send an identifier to the user, which we can then load when we receive the session. We need to set the session to HTTP only, which means that the cookie or a session is not accessible from JavaScript. And we want to set the cookie to secure, which means it can only be sent over HTTPS. I rely on the JSON Web Token provider to validate the token that lives inside of my session, but near the token is not coming from the authorization header, but it is coming from the session itself, right? So I access the user session, I extract the token, and I create the HTTP auth header type that Ktor expects to validate the token, right? So here I'm simulating that the token inside of my session is an authorization header. And this will make sure that it relies on all the mechanisms we need from JSON Web Tokens and JSON Web Keys to validate these tokens. We can override an optional challenge function because we do not want to send an unauthorized code to the user. Again, we want them to be redirected to some page, in this case, the login page. To protect our route, we already wrapped it in Authenticate, and we can pass multiple authentication providers for securing this route. So we have set up our server, our dependencies, our routes. We've set up security. We've almost done everything. So now it's time to deploy our application. And we come back to Gradle, because we want to configure Gradle for building and deploying our server. And we include the Ktor Gradle plugin using the version catalog, which we set up in the beginning. And the Ktor Gradle plugin comes with the application plugin, such that we can set up the main class for our server. And remember, when Kotlin compiles to the JVM, it adds a KT postfix to your class name for the JVM file. So you need to explicitly specify this KT postfix. Once we have done that, we can create a fat jar, which runs anywhere where the JVM is available, which is quite convenient, but also a little bit outdated. So in modern systems, we typically work with Docker images, which is supported by the Ktor Gradle plugin. And here I'm specifying a version or an image tag, and I'm configuring an external registry, in this case, GitLab. But I'm personally using Docker Hub, not GitLab. There's also support for Google Container Registry, but as you saw, it was very easy to configure any registry. There is support for customizing the base image in case you do not want to use the default image. And you can also add additional port mappings. But sometimes this is not all we need to go beyond. And the Docker support in Ktor is built on top of the very well-known Jib Gradle plugin. And you can use the Jib Gradle plugin to do any additional configuration you want to your container. And in this case, I have a simple example where I'm setting up the OpenTelemetry Java agent to automatically instrument our Ktor service and any dependencies that we might have that need to be instrumented. Right? So this makes sure that we can have zero configuration OpenTelemetry support. So what do I hope for you to take away from this talk? Well, first of all, embrace the application DSL. Right? It's the core of the Ktor library. I think it's a strong type to include in your dependency graph. It allows you to run coroutines. And with that, I want to say, embrace coroutines. Ktor is a framework built on top of coroutines. It allows for extremely powerful patterns, as we saw for processing events or SDK integration. But you always should set a dispatcher explicitly. And finally, Ktor is a simple framework that has everything out of the box for you to do, but it gives you full control in how you build your services, so keep them simple. Don't over-architect your services. Keep things simple and easy to understand so that everybody can start working in your service, not only yourself or your agents, but everyone. And with that, I want to thank you all for coming to my talk. You can find all the relevant information at the QR code. And I think we still have some quiet time for questions. But again, thank you all so much for coming to my talk.
I just wanted to ask, you were using YAML for config, and a thought I had is that you could probably express that config just as easily just by instantiating it in Kotlin without using any YAML.
Right.
Is there any benefit to using YAML over just doing that?
So Doing the configuration at runtime, I think, is also a great option, and I've done so in the past. But as I mentioned, YAML is becoming the standard for DevOps, and typically we're not working ourselves. DevOps people typically don't want to look at the code, so if you're working with other people, it can be very interesting to have this application YAML specifically for working with other teams.
Okay, cool. Can I ask one more question? You said to always specify the dispatcher when you're using coroutines. Could you elaborate on that a bit more?
Yes. So the application type in Ktor by default has no dispatcher set, right? So it has an empty dispatcher. It is only a supervisor job, so it's important that you always set the dispatcher. Otherwise, it's running without a dispatcher. Also, if you have any more questions during the coming days, you can find me at the JetBrains booth, and you can bother me about anything in Kotlin, server-side, or functional programming.